So for this one, oh Tim, I'm making a video, so you can just ignore me. So for this one, I think you were right. I don't remember the Pythagorean identity, so I'm going to write that down real quick. So you were right to think about splitting it up. I think you did. You split it up with tangent to the second times tangent to the second. So that's what I'm going to do as well. And then you just try stuff. So we have this dx. If I made u, if I did u substitution, I made u tangent, then it still wouldn't work out. So I can't really do that. I have to do some more. I'm going to try and change it. I think like what you did here. Yeah. So what do I have? I have the integral from 0 to pi over 4. There was a long pause just now. I don't remember what I was saying. So, yeah, I'm just going to continue on what I was doing. I'm going to use this, and I'll change one of them. Why one of them? Well, you'll see in a minute. Usually you do this. This is a trick that you normally do. So this, if I move this over, it'd be secant squared theta minus 1, not theta, x minus 1 dx. And then we have, well, I know that the derivative of tangent is secant squared, so I can make my u value into tangent. Oh, maybe I'll put this on the test. This would be a good one. I'm not going to do that. So just tangent x, so du equals secant squared. You know what? It doesn't get rid of that. You can't cancel stuff out, so I got to do something else. But I have tricks for that. So prematurely I was making my u value. I'm going to simplify this a little bit more by distributing. So I have 0 to pi over 4 tangent squared x secant squared x minus tangent squared x dx. Split up the integral. So this is tangent squared x secant squared x dx. I can definitely use u sub here because if I make u tangent, the derivative is secant squared, so it'll cancel that out. So that'll be sweet. And then I have minus the integral from 0 to pi over 4 of tangent squared x. So now here's my trouble. Now I need to do stuff. That one might give me a little bit of trouble, but we'll try and think of ideas for that. This one I can definitely do. U equals tangent x, du equals secant squared x dx. So that means dx equals 1 over secant squared. So then I have the integral from 0 to pi over 4 of u squared, and then that is going to cancel out with that. This is dx there. Sorry, du. Right? So I replace the dx with this, and those will cancel. And I got just du. So that's cool. I'm going to leave that. You can finish that one. This. What do I do with this? I'm going to pause it and think about it. I don't know yet. My first idea that I have in my brain is to use a reduction formula on this. Instead of being a squared, it'll be something else. But I feel like that might get messy, so I'm trying to think of something else. But I probably will have to look that up if I do use it. I figured it out. So I have an antiderivative formula for secant squared. So I'm going to change this into minus the integral from 0 to pi over 4. This will be, we decided already, secant squared x minus 1 dx. I'll split this integral up again. You just got to be careful because of this negative. So it's negative 0 to pi over 4 secant squared x. I have an antiderivative formula for that. And then this minus and this minus become plus. It's like you're distributing this into both pieces, right? So then we got I don't know why I say right, because you can't answer me. So what am I doing that for? I don't know. But look, there we go, the dx. I can definitely do that and get a number. Definitely do this. The antiderivative of secant squared is just tangent, because the derivative of tangent is secant squared. And then you could do the antiderivative of 1, and it's just x. So hopefully you can finish it up from there. Took me a minute. I had definitely took some time to think about that. But there you go. That's what you do. Bye.